So today's question is Trionic array second. So you are given an integer array nums of length and then we have to find the Trionic subarray, which is a contiguous subarray where 0 is less than equal to L less than R less than N, and for which there exist indices L less than P less than Q less than R, such that nums L to P is strictly increasing, nums P to K is strictly decreasing, and nums Q to R is strictly increasing. So we have to find a graph. Suppose it is increasing, then decreasing, then again increasing. So we have to return the maximum sum of any Trionic subarray in nums. So first of all we have to find the Trionic subarrays, and then we have to find the sum of the Trionic subarrays, the maximum sum among those all Trionic subarrays. So let's try to code this. First let's take the length of nums. Let's set answer as float infinity currently, so minus infinity, as we have to find the maximum value. And then we can set our first pointer like first pointer I at 0. Okay, now let's get the loop while I is less than n, and let's try to find our Trionic subarray. So first let's put a pointer at j is equal to I plus 1, and for calculating their sum let's create a value result and keep it initial value is equal to 0. Now let's find the increasing part of the graph. So while j is less than n and nums of j minus 1, nums of j minus 1 should be less than nums of j, as it is an increasing one, and if it's the case we can simply increment the j value. And after completing the loop, suppose let's take a variable p will be the peak of the graph. Okay, so let's take p is equal to j minus 1, and suppose if p is still equal to I, then it means there is no increasing segment, so we can simply increment the I value and continue. We will increment the I value and again find for the new increasing segment. And suppose if there was an increasing sampling, so we can simply add the result of the values, result at the peak value plus result just below that. So nums at p minus 1, the index below that. Okay, we can sum that. Now let's find the first we have found the increasing, we will find the decreasing part of that. So while j is less than and nums at j minus 1, this time it's greater than nums at j, because we are in the decreasing, we are finding the decreasing one, so we will simply add its value to the result plus is equal to nums at j, right, nums at j, yeah. And then we can simply increment the value, j plus is equal to 1, and now the down point, the value of our graph, we can set it at q is equal to j minus 1. Now suppose if q is equal to p, if q is equal to p, then, or if q is equal to p means we have not found any decreasing point, or suppose q is equal to n minus 1, so we have got the decreasing but it's not possible to find the next increasing element. Or suppose j is less than n and nums at j is less than nums at should be less than equal to nums at q, means there is no increasing part, elements are there but there is no increasing part. In that case we can simply set I is equal to q and we can continue, no further to go, yeah, continue. And if it's not the case, then in the result we can simply add the value result plus is equal to nums at q plus 1, because we have already added the q part. Okay, now we have got the result. Suppose let's take an example, 1 2 4 4 2 1, anyone. Suppose this is an increasing part, suppose this is a Trionic subarray. So we have got the sum of this. Now we want the maximum towards right we can get the sum, as we want the maximum sum of the subarray, and maximum towards the left we can go. So we will be using Kadane's algorithm here to find the maximum subarray sum. What Kadane's algorithm does, anywhere if it reduces the current sum, then we don't take that particular integer or that particular value. So first take Kadane's algorithm for the right pass, how far we can go so that our sum increase and the condition is satisfied that it's in the increasing part. So let's do that. So first let's say max sum is equal to 0, then we can set current sum also is equal to 0, and let's say k is equal to q plus 2 because we have already added till q plus 1. Okay, now simply run a loop while k is less than and is to satisfy the condition. What condition? Nums of k should be in the increasing part of the graph, so num of k should be less than nums of k minus 1. Nums of k should be less than nums of k minus nums is not less, it should be greater enough. Yeah, should be increasing part, so nums of k should be greater than nums of k minus 1. Yeah, correct. So simply we can increment the current sum value, current sum plus is equal to nums at k, and then we can take maximum sum as maximum comma current sum. Okay, and then we can simply add this value in the result plus is equal to max sum. Now we have got the sum toward the right of this. The maximum sum of the subarray will satisfy the condition, and how far we can go, we have taken that sum. Now we have to calculate this left part. So how far we can go to the left where it satisfies the condition, and we can get the highest result. So we can simply again create maximum is equal to 0, current sum is equal to 0, then for k in range, what will be the range first, how till which point we have added p minus 1 we have added, so we will simply take p minus 2 to the range I minus 1. I is from where that increasing segment is increasing, we can go till there only. So current sum plus is equal to num set k, and similarly max sum is equal to max of max sum comma current sum. So here also we get our max sum, that we will just add it to the result plus is equal to max sum. And yeah, so we can simply, we have defined this answer, we can simply take the max of that. So answer is equal to max of answer comma max of answer comma this result, which is the sum of the Trionic subarray, maximum sum of the Trionic subarray which we can get. And we can simply set the next I value at the q, because till q we have found the maximum value, and at last we can simply return this answer, return answer. Let's try to run this. Is it some glitch? Taking some j plus 1 is equal to 1. Time limit exceed, we must have missed the increment. This, see, we have not incremented the k here. K plus is equal to 1, other any such mistake somewhere else. J plus is equal to 1, here also we have increased. Let's try to run now. Yeah, so our test cases has passed. Let's try to submit this and check if it works for all the test cases. Yeah, so our code has passed successfully. Thank you for watching.